Alright, so today we're diving into the world of kinematics, specifically the kinematic equations that describe motion with constant acceleration. Whether it's a car speeding up, an object in free fall, or a rocket launching into the sky, these equations help us predict position, velocity, and acceleration with precision. Let's start with the basics. Kinematic equations are a set of four powerful equations used to describe the motion of objects when acceleration is constant. These equations help us calculate key aspects like position, velocity, and displacement, and are widely applicable in physics problems. The first equation, v equals u plus at, allows us to calculate the final velocity of an object when we know its initial velocity, acceleration, and the time it has been moving. This equation is useful for determining how fast something is moving after a certain amount of time. For example, let's say a car starts from rest, meaning its initial velocity, u, is 0, and it accelerates at 3 meters per second squared for 5 seconds. How fast is the car moving after 5 seconds? Using this equation, let's find how fast the car is moving after 5 seconds. After 5 seconds, the car is moving at 15 meters per second. Easy, right? Next up, we have the equation for displacement. S equals ut plus 1/2 at squared. This one helps us figure out how far an object has moved given its initial velocity, acceleration, and the time it's been traveling. Let's say you drop a ball from rest, meaning u is 0 again, and you want to know how far it's fallen after 4 seconds, assuming gravity is 9.8 meters per second squared. Initial velocity is 0. Acceleration is 9.8. Time is 4 seconds. Using this second equation, input the values. After 4 seconds, the ball has fallen 78.4 meters. Now, onto our third equation, v squared equals u squared plus 2as. This one is great for situations where you want to know how far an object has traveled without needing the time. It connects initial velocity, final velocity, acceleration, and displacement. Let's try a new scenario. A car starts at 10 meters per second, accelerates at 2 meters per second squared, and you want to know how far it has traveled by the time it reaches 30 meters per second. Using the equation v squared equals u squared plus 2as, we substitute in the values. 30 squared equals 10 squared plus 2 times 2 times s. Solving this gives s equals 200 meters. The car travels 200 meters before reaching 30 meters per second. Finally, we have s equals 1/2 times u plus v times t, which gives us displacement based on the average velocity. This equation is especially handy when you know both the initial and final velocities, but not the acceleration. Let's say you're riding a bike starting at 5 meters per second and speeding up to 15 meters per second over 10 seconds. How far do you travel during that time? Initial velocity, u, is 5 meters per second. Final velocity, v, is 15 meters per second. Time, t, is 10 seconds. Using this equation, input the values. So you'd cover 100 meters in that 10-second span. Now that we've covered all four kinematic equations, let's see how they come together in real-world applications. Whether it's calculating how far a skydiver falls before pulling their parachute, or figuring out how much distance a car covers while accelerating on the highway, these equations are the foundation of motion analysis. Let's test your understanding with a few practice problems. Pause the video if you need more time to solve them. One important thing to remember is that the kinematic equations assume constant acceleration. Real-world motion can involve variable acceleration. Think about a car driving on uneven terrain or a roller coaster's sudden changes in speed. In these cases, more advanced techniques are needed to analyze motion. So to recap, the kinematic equations allow us to calculate velocity, displacement, and acceleration in situations with constant acceleration. Understanding and mastering these equations will give you the tools to solve a wide range of motion-related problems. Thanks for tuning in. If you found this helpful, make sure to subscribe and check out kingofthecurve.org for more practice problems, tutorials, and resources to strengthen your understanding of physics and beyond. See you next time.